You heard about the salt, na? Salt bed. Salt bed. Huh? Where are the salt beds? Salt bed किधर है? Pakistan में. Most of the those area countries, there is salt beds. India में salt bed नहीं है, बहुत कम है. But Mexico में है. Salt bed is a very thick deposits of halides, sodium chloride. So you must be visiting sometimes, to the western coast of Bombay. You will find many salt deposits. But salt beds are very thick deposits, maybe hundreds of meters. Thick beds are there. They alternate with shale sandstone. They are all sedimentary rocks, but very important for oil deposit, hydrocarbon. Suppose I ask you, salt bed is a solid, liquid or a ductile material? Could you understand my point, na? Suppose I ask you quartzite, you say it is a brittle metal. Same quartzite, if it occurs 20 km below or 10 km below, you say it is a ductile quartzite. Salt bed, which occurs at the top, so like Bombay, sometimes you could visit Wasi. On the way, you will find many salt deposits. Salt beds are there, very thin salt beds. Could you follow this point? So they are brittle or ductile. Salt are always, though they appear very brittle, solid, they are just like water, liquid substances. Can you imagine? Though it appears while eating, you must be observing, but it behaves, so far as the property is concerned, it behaves like a liquid. What is the behavior of a liquid? With very little amount of stress, or even no stress, it will start flowing. That is what we read in that day. A brittle material will not flow. Brittle material, you press it, it will take some strain and come back to its original position. You follow the brittle materials. But what about the ductile or the liquid materials? With very little amount of stress, their property is such, it will start flowing. Suppose honey, you just keep honey. It will automatically start flowing like this, Water, you keep it here. With little slope, it will start flowing. That is the property of liquid. Now, so by observing, by touching it, you can say it is a liquid. But salt, if you touch it, it appears like a solid substance. Now, this salt bed, when you, like in a basin, a salt is deposited like this, a salt bed. Bhavnagar में जाओगे ना बहुत salt bed मिलेगा, salt mines, very solid substances. Now, over that you put sandstone. Suppose sandstone is deposited, shale is deposited. It is sedimentary rock. These are evaporates. Because evaporation salt is precipitate. Now you put sandstone and shale in sequence. After some time, the salt bed will not stay there. It will not stay there. Just like a liquid, it will start. It will start flowing in solid form. It will not appear soft. In solid form, it will start flowing. So this will go up and spread here. What is point now? So though it appears like a solid substance, but it behaves like a viscous. Though it appears like solid. Follow this point now. So it is a solid or it is a liquid. It is a liquid, you can say, with high viscosity. Just like the mantle material. Mantle में, that I told you, below lithosphere you have asthenosphere. So this material is in this form. They are not like water. They are like the salt. इसलिए तो एस पी पास करके जाता है ना. सॉलिड सब्सटेंस है, but they will behave like a liquid. थोड़ा सा यहाँ एक्सटेंशन हो गया, so there is some extension here. You start flowing. So then it will start separating these plates into two parts. So that is the type, the liquid with very highest viscosity. Similarly, salt is a liquid with very high viscosity. So it will start up, and sometimes you will find salt domes within this. Salt diaphragm, you say salt diaphragm, salt dome. This is the overflow. They are all called salt flow or salt. Different names are there. So all these are covered. Last class I was covering initially under salt tectonics. Because salt tectonics is very important from oil point of view, hydrocarbon point of view. So they are the sites for hydrocarbon deposition. Because when they rise, the overlying strata, suppose this salt diaphragm is occurring like this, from below it is coming up. All these things it try to push, ऐसे push कर देगा. So these are the areas where hydrocarbon occurs. Similarly, this salt dome is little, this area hydrocarbon. Understood this part, na? That is why salt dome is very important from hydrocarbon point of view. So salt occurs within the brittle layer. Within the brittle layer of the crust, but they behave as a liquid. So they are very important for oil point of view. But India does not have a salt deposit. Otherwise, you will have many such oil deposits in Himalaya or foothills of Himalaya. But now whatever oil deposits we have, they are all in the sea. All in the sea. Okay, so that is a different thing. But first, try to understand the significance of salt. It's just like a mental substance. Now see, suppose I classify the materials, brittle and ductile. So you understand now what is what. Now, this brittle substance, as I told you, the stress, whatever stress you bring, it is proportional to the strain. Follow this point. This is very easy, but the significance you see. Suppose you have this crust, has 12 km of the crust. Has 12 km. This is brittle. So if there is a stress, this stress, I told you maximum stress is needed to break the rock. Whatever stress is built up within, it cannot do anything. So you have to have an external stress, then the things will deform. So this part of the crust will deform, by developing these fractures. Fractures will deform. Fault will be created, fractures, fault. Those are things which will form within this 12 km. Just like you imagine, you have a chalk. Chalk आपके पास है, and you are pressing it. Like this, and if you press it, chalk will break. It will form powder, it will form fractures. Like the mine people, they break, or the road making people, they break the larger boulders into small pieces. So that type of deformation, takes place. So this deformation, you can say to the broad name called cataclasis. You are powdering the rock. You are powdering the rock. So the deformation within the brittle layer, the brittle deformation you can say, cataclasis you can say. So follow this point. Here, whatever deformation, fractures you are creating, fault you are creating, so they are directly proportional to the stress. Stress कितना आप apply कर रहे हैं, उतना strain produce होता है. In the field, that day we went for a field work, we found some faults. Similarly, if you work in an area, go for field work, find many such faults are there. So from these faults, their orientation, take, strike, deep. If you take their strike and deep, and there will be slicken sides on the fault surface. Like suppose this is a very big block, you may find a fault plane passing through it, and there will be lines over it. So these are the slicken sides. On the fault plane, there will be small lines, indicating the slip direction. This is how the faulting is determined. So if you have this data, strike, deep, this lineation data with you, you can calculate the stress. How much stress was working there, you can calculate. That day we saw strike deep we have measured, slicken side measurement also we have made. So this time when I will take the lab class, I will tell you how to calculate this. How much stress is applied over it. इतना इसमें stress गया है, you can calculate. Because stress is proportional to strain. Strain means your fracture, fault. So which is manifested in form of strike, deep, and some lineage. Follow this point now, because strike and stress and strain are parallel. They are proportional. Similarly, in oil exploration, suppose you are drilling. So this is a basin, Bombay basin. Let us take the Bombay basin. Bombay basin. Bombay basin में क्या है आपका? The top part of the crust. These are all brittle structures. So these layers, where oil is occurring, they have been faulted, fractured. ऐसा है. उसका अंदर oil का है. Now suppose you are drilling here. You cannot see these fractures because they are inside. Now from this borehole data, you can calculate how much stress is working here. Because whatever deformation is going on here, whether it is a fault or fractures, all those things are related to stress. तो क्या करते हैं लोग बात यहाँ डाल के borehole, they put some oil in hydraulic fluid. Hydraulic fluids. Understand that hydraulic fluid, lot of compression, they are forced to pass through these fractures. So the fractures get wide open. So कब वो wide open होता है? What point the wide opening is taking place? Same as this stress you are applying from the top. आप सब जगह फुटबॉल है, फुटबॉल में आप हवा देते हैं. फुटबॉल का स्ट्रेंथ कब मेजरमेंट करेंगे? जब वो फटेगा. इतना में हवा जब दिया तब फुटबॉल फट गया. So तो उसका चमड़ा का strength is this. Like this, you go on pushing hydraulic fluid into it. So this is a specific test, I'm just telling in a very common language how this stress is calculated in a borehole. So they put hydraulic fluid when this ruptures, they calculate how much sigma 1 is working. So if time permits, I will cover these things towards the end. Otherwise, last year I have covered in very detail. You can see those videos. You don't understand these things, na? This is called leak of test. Leak of test. To know the in situ stress in the oil field. ये necessary है. Because आप नहीं तो कैसे एक्सप्लोर करेंगे ऑयल कितना प्रेशर में है वहाँ नीचे. Unless you know that, you cannot put borehole को फटा देगा, काट देगा. This is very essential. Because these are all brittle deformations. Brittle deformation में stress and strain. Yeah. You follow this point, na? That is why you can calculate stress. आप फील्ड में काम करते हैं, you get some fault planes, slicken sides, you can calculate stress. But if you go to a folded terrain, a fold, अभी ductile layer, where 12 kilometer below. If you go below 12 kilometer, this material. So what are the structures? When there is some external stress, there is no fracture because rock flows there. Na? The deformation is guided by flow law, viscosity law. तो यहाँ आपको क्या मिलेगा? ऐसे फोल्ड मिलेंगे, Understood ना? What else you will get? Suppose folds are not there, you may get the grains, the quartz and feldspar grains. They are all stretched. You may get a fold, you may get a cystosity plane. Cystosity भी आपको मिल सकता है. These are the cystosity. The alignment of the grains. Mica, you may get mica grains aligned like this. Mica, quartz. So the define is cystosity or foliation. Those things you will get. You will not get any fracture. Now, by observing these things, what you can calculate? You cannot calculate the stress. Stress you cannot calculate. Why? Because stress is not proportional to strain there. अब जो डिफॉर्मेशन कितना बड़ा फोल्ड बना है, it has some amplitude. So there is a fold like this. It has wavelength. It has amplitude. By observing this wavelength and amplitude, you cannot say how much stress was applied there. Because ये जो fold आप देख रहे हैं, that is not proportional to your stress applied. Because ये viscous material है और ये ductile material. Unlike the brittle materials. You want to follow this point now. So in this case, what you can calculate, from this W values or A values, thickness of the layers, which is called T values. These are the things which are associated with a fold. Similarly, suppose there is a cystosity plane. The grain dimension of the grains, orientation of the grains. So these are the features which you can measure from a ductile. So there what you can calculate? You can only calculate strain. Because stress is not proportional to, only you can calculate how much deformation is taking place. How much deformation I will tell you. इसका significance क्या बोलता हूँ आपको. Suppose you have a ball. Suppose you have a ball. Now, if it is brittle, क्या होगा? आप इसको प्रेस करेंगे, ये टूट जाएगा, दो पीस हो जाएगा ऐसा. In brittle state. But if it is a ductile material, if you press it, what it will happen? This will become a line, ellipse. So this ellipse, इसका size जो है, इसका size है long axis, short axis है. The size of the ball, it does not depend on how much 3 MPa आप दे रहा है, 5 MPa दे रहा है, इसका को डिपेंड नहीं करता है या नहीं दे रहा है. आप देखो, तो मुझे इतना बॉल है, आप इसको धीरे धीरे प्रेस करो, वो आने प्रेस करो, वो भी ऐसे हो जाएगा. एक दिन आप इसको जल्दी से प्रेस करो, तो ऐसे हो जाएगा विदिन 1 year. आप इसको प्रेस करो, विदिन हाफ डे इट विल बिकम लाइक दिस. Same stage, same amount of ellipse you will get with a different amount of stress. Because it is a ductile substance. Understood ना? इसलिए ये आप कैलकुलेट नहीं कर पाएंगे. आप क्या कैलकुलेट कर रहे हैं? मैक्सिमम हाउ मच डिफॉर्मेशन लॉन्ग एक्सिस बाय शॉर्ट एक्सिस. एक इतना ही डिफॉर्मेशन हुआ है, आप कैलकुलेट ओनली क्वांटिफाई द डिफॉर्मेशन. बट इसका जो कॉज है, कितना स्ट्रेस आप दिया था, दैट इज बियॉन्ड कैलकुलेशन. आप कर ही नहीं सकते. विद रिलेशनशिप इज नॉट स्ट्रेट फॉरवर्ड लाइक ब्रिटिल. इतना डिफॉर्मेशन हुआ, आप कर नहीं सकते. हाँ, वो भी कर नहीं सकते. मैं बताता हूँ आपको. What he is asking, suppose you have a ellipse line. say at least from this side it has been pressed. That is what he is telling. At least the direction हम कर सकते हैं. मैं क्या रिप्लाई दे वो भी नहीं कर सकते. Amount तो छोड़ दीजिए कितना, but even direction you cannot say. I will tell you how. Now you see, अब suppose ऐसे ब्लॉक ठीक है, ये ब्लॉक सॉफ्ट ब्लॉक डक्टाइल मटेरियल है, सॉफ्ट ब्लॉक. नाउ inside this you draw the circles. Inside this you draw the circle. Now you trace it from this side. What you will get? You will get the block has become like this and the ellipse are oriented this way. That is what you got. Now same thing, you give a shear like this, you know. You give a shear like this. Don't press. Understood na? Because you shear it like this also, all the circles, you know, will become ऐसे हो जाएगा. Some ellipse you will get. So in the direction here there is no pressing भी नहीं है. या pressing कहीं हुआ होगा, but shear is working over. Understood ना? Not only that, आप क्या करो, आप इसमें ये जो मटेरियल है ना, आप एक मैं बताता हूँ आपको, हार्ड प्रोसीजर आई एम टेलिंग यू. मैं 2-3 सर्कल डालता हूँ इसका, ऐसे सर्कल डाल दिया. मैं क्या किया, आई एम कीपिंग लेयर बाय लेयर, लेयर बाय लेयर, लेयर बाय लेयर, लेयर बाय लेयर, लेयर बाय लेयर एंड ड्राइंग सम सर्कल्स ओवर. समझा कि नहीं समझा? तो व्हाट आई एम डूइंग, आई एम टेकिंग आउट वन लेयर, ये लेयर को बाहर निकाल के फेंक देता हूँ. तो व्हाट विल हैपन टू दिस सर्कल? आर एबल टू फॉलो दिस थिंग और नॉट? सी नाउ सी सपोज यू हैव ए stack of card, 1 card, 2 card, 3 card, 4 card, 5 card, 6 card. These cards are there. Over there I have drawn the circles, you know. ऐसे से circle draw करके रखा. Now I am removing 1 or 2 cards, 1 or 2 cards. फेंक देता हूँ. वो circle क्या हो जाएगा? सब ellipse बन जाएंगे. ये भी एक mechanism हो सकता है. तो not only ellipses are produced by pressing, compression, by shearing can also produce. Now what is this procedure? This procedure, volume loss. तो मटेरियल बाहर निकल गया, यहाँ से कुछ सॉल्यूशन आया, सॉल्यूशन करके इसको निकाल दिया. So it is also called volume. A volume loss can also produce ना ellipse. समझा नहीं? ऐसा आप यहाँ आगे सर्कल डालो, डाल के एक पीस निकाल दो, अल्टरनेट पीस निकाल दो, इट विल बिकम एन एलिप्स. तो यहाँ से तो ये छोटा हो जाएगा. समझा कि नहीं समझा? दिस इज कॉल्ड वॉल्यूम लॉस. सो वॉल्यूम लॉस कैन प्रोड्यूस स्ट्रेन, shear can produce strain. Strain means a circle becomes an ellipse. So because of these reasons na, you cannot compute on stress by observing a deformed rock in a ductile medium. But brittle में होगा. Brittle में you can calculate stress. वो थोड़ा बाद में बताऊंगा क्योंकि I have covered it. You can see the videos. But we will be giving importance to ductile part. समझा कि नहीं समझा मेरा बात? So
So if we apply a stress in an angle, so we can determine the direction.
If you apply a stress to ductile material, you are telling. Suppose the ductile material is here. You are applying a stress like this. This is what you are telling. The circles are like this. Then what you are telling? क्या डिटरमाइन करने का?
सर आप डायरेक्शन की बात कर रहे थे, डायरेक्शन
डायरेक्शन नहीं बता पाएंगे। आप सपोज यू ऑब्जर्विंग इन एलिप्स लाइक दिस, यू कैनॉट से दैट ए से स्ट्रेस हो रहा है।
सर अगर रोटेशन होगा तब तो हम बोल सकते हैं।
हाँ?
अगर रोटेशन हुआ
रोटेशन मीन शियर ना, ऐसे शियर होगा, ऐसा सपोज शियर हो गया तो ये भी ऐसे हो सकता है, या वॉल्यूम लॉस होने से भी ऐसे हो सकता है। So there are different ways of producing this type of strain because this strain is not proportional to the stress. वो किसी कारण से कैसे भी हो सकता है in a ductile medium. Maybe I am unable to understand your question. थोड़ा हिंदी में बात करें, बताओ क्या है? नहीं ना, क्लियर एंगल में केस क्या बता? क्या बता?
सिंपल और प्योर में, जैसे प्योर शेयर में रोटेशन नहीं होता है, बट
सिंपल में रोटेशन होता है,
यस
प्योर में रोटेशन नहीं होता। ये प्योर शेयर हुआ ना। आप जैसे ऐसा एक ब्लॉक है, आप प्योर शेयर मतलब क्या है, ऐसे प्रेस करेंगे दिस सर्कल विल बिकम एन एलिप्स, दिस इज प्योर शेयर।
यस
सिंपल शेयर क्या है, ये जैसे ब्लॉक है, आप ऐसे शेयर दे दिया है, सपोज दैट इज अ सर्कल, दिस विल बिकम एन एलिप्स, ऐसे एलिप्स होगा। यह कंप्रेशन इन्वॉल्व नहीं है, जस्ट एन रोटेशन। और यू जस्ट गिव ए वॉल्यूम लॉस टू इट, ऐसे सर्कल था, यू गो ऑन रिमूविंग द कार्ड्स फ्रॉम लाइक दिस, देन इट विल बिकम आल्सो एलिप्स। थ्री वेज ऑफ प्रोड्यूसिंग द एलिप्स।
सर इस सेकंड वाले केस में हम ये बोल सकते हैं ना कि इस डायरेक्शन में स्ट्रेस लग रहा है।
यहाँ स्ट्रेस काम नहीं किया है, ऐसे बोल रहे हैं ना आप,
यस
ऐसे तो स्ट्रेस काम ही नहीं किया, काम ही नहीं किया है, देयर इज नो स्ट्रेस। आप देखो कैसे होता है, मैं बताता हूँ आपको। यहाँ स्ट्रेस काम नहीं करता, यहाँ ओनली रोटेशन इज इन्वॉल्व। आप देखिए, मैं बताता हूँ आपको, तो टेक्नोलॉजी क्लास की बात है। अब देखो जब हिमालय कैसे प्रोड्यूस हुआ हिमालय, सो वन साइड वाज इंडिया प्लेट, अनदर साइड वाज चाइना प्लेट, बीच में एक टेथिस ओशन था, टेथिस ओशन था। Now टेथिस ओशन वाज सम 10 to 15 किलोमीटर थिक सेडिमेंट्स वे आर, इसके अंदर उसको सेडिमेंट डिपॉजिट हुआ। नाउ इफ आई आस्क हाउ यू विल प्रोड्यूस हिमालय आउट ऑफ इट, कैसे आप क्या बोलेंगे आप? ये दोनों को ऐसे, ये प्लेट आया, ये प्लेट आया, ऐसे प्रेस कर रहे हैं, बट एक्चुअली नेचर इट डज नॉट हैपन। ये चाइना प्लेट क्या है, ऊपर ऐसे उठेगा, ऐसे इंडिया प्लेट ऐसे जाएगा, एक प्लेट नीचे जाएगा, एक प्लेट ऊपर जाएगा। व्हाई दे डोंट कम टुगेदर? टुगेदर में आप क्या कितना सर्टेनिंग कर पाएंगे? कर नहीं पाएंगे। तो इसलिए एक रोटेशन में बहुत स्ट्रेन होता है। तो वहाँ कंप्रेशन क्या है, कंप्रेशन किधर से आया होगा, बट बिकॉज ऑफ दिस कपल ना द डिफॉर्मेशन टेक्स प्लेस। समझे? ये एक्चुअली ये स्ट्रेस नहीं है, एक्चुअली इसे स्ट्रेस नहीं है ना। आप देखो जैसा there are some horizontal thrust sheets are there, horizontal thrust sheets. So this is a shear zone, horizontal shear zone. ये ऊपर जाता है, ये नीचे आता है, horizontal. यहाँ सब एलिप्स कैसे हो गए, ऐसे एलिप्स हो गए, ऐसे एलिप्स हो गए, ठीक है ना। बट कंप्रेशन इज नॉट फ्रॉम टॉप एंड बॉटम, ऐसे कंप्रेशन नहीं है। कंप्रेशन तो कैसे इधर से भी आता होगा, इधर से भी आता होगा, nobody knows. But because of this strain, because of this couple, this strain is ये अच्छा, ठीक है।
So if somehow we know that this rock has undergone only pure shear,
हाँ,
then we can say कि in which direction stress is applied.
तो आपको निकालना पड़ेगा whether it is only pure shear.
But suppose if we can find it, then
it's okay. It's okay. Okay. Now you understood now why you cannot calculate this stress in a ductile medium. Only strain you can measure. Corpuscle, corpuscle, fold, oolites, only strain can be calculated, no strain. The point is, यहाँ मैं बताता हूँ, suppose this is a ductile medium. ठीक है, इसको हम डिफॉर्म कर रहे हैं, डिफॉर्मिंग है। नाउ हाउ द डिफॉर्मेशन इज टेकिंग प्लेस, इंट्रोडक्शन आई गिव मैं ऐसे बताता हूँ, सपोज you have a very big house in your village, a very big house. What type of house you are understanding now? Thatched house, mud. This is your H-U-I, or H-A-Y, A-Y, like this, Suppose you have a house like this. Here there are no windows. Village side you will get. Cities you will not get. Now, suppose you have a house like this in the village side, and cyclone came. Suppose the cyclone came like this. Cyclone came. Cyclone came. So what will happen to this house? This house will now, imagine, this will deform. It will be demolished or it will be destroyed, something like that. Very large cyclone came. So people are staying inside this, the cyclone came and they are taking shelter inside it. Now this house, so naturally it will become something like this, So this top part will be tilted. So this part may be straight, partly it is still staying straight, partly it is destroyed, ऐसे कुछ हो गया. Some part it is broken, Some part, this part got broken. It is still standing here. I'm little. यहाँ से ब्रेक हो गया, टूट गया. इधर से the windows थे, ऐसे सब हो गए. समझा ना? You are understanding point ना? So now imagine करो, ये से ductile में, because ductile से this type of deformation took place. Imagine करो cyclone आया, and house को आपका घर को तोड़ दिया. And if people are staying inside, it is raining outside, wind is blowing, we have so many 20 to 30 people are staying inside. So what will you do? What will you do? So you will definitely repair it. Otherwise, how will you stay for 3-4 days? Last time filing came, stayed for 7 days, in Odisha. But people ऐसे टूटा हुआ मकान में रहते थे. कुछ तो करेंगे ना. इसको कुछ बांबू लेके इधर डालेंगे, ऐसे कुछ करेंगे. Now, वो क्या किया? ऐसे भाई इसको थोड़ा सा ठीक कर दो ऐसे. करके इसको छोटा सा मकान बना दो, और नहीं तो एक छोटा सा मकान इधर बना लो. ऐसे किया ना. इतना बड़ा मकान को तो रिपेयरिंग करना is not possible during and same time also the cyclone is coming. Cyclone is not stopped, It is going on, it is breaking it. Again it is breaking. छोटा छोटा करता है. फिर they are making it small. कैसी बढ़ा रहो का दिन का. Understood this part now? Now when the filing is over, then people came out and they got some funding and made a very big house now. Maybe with concrete. You understand this part now? तो यहाँ क्या था? It was very undefined. कुछ नहीं हुआ था इसको. Now the cyclone came. समझा कि नहीं समझा? तो ये आके इसको तोड़ दिया. Because material was weak. Had it been a concrete house, कुछ नहीं होता उसको. City में कुछ नहीं होता. But since the material is weak, because it is soft, and if there are so many windows, air can go inside, wind can go inside. The roof is not attached. Have you seen a thatched roof? Village में देखा होगा ना, यहाँ gap होता है. इसका अंदर घुस के wind जाता है. तो इसको उड़ा के ले जाता है. You must have seen, because the material is weak. So they got demolished. ऐसे टूट गया. तो कई तरीके, अब जब एक सुपरवाइजर आएगा आफ्टर 7 days, he will see, this has been, what has happened to it? This has been tilted. This has been tilted. What happened to the roof? Roof has been flown away. Flown away. Like the statements will make, Agree? So this has been crumpled, it has been crumpled. The door has been tilted to the other side. Like this, so many statements will make, to describe this deformation. वो कुछ टर्म होता है सुपरवाइजर का वार्ड में. बट आप लोग क्या कहते हो, घर में थे, when the cyclone is blowing, you are not sitting just to face the fury of cyclone inside the house. You are making small houses out of it. क्यों? Just for your shelter. follow this point ना. इसको ऐसे आप बैठा नहीं रहते थे, आप बनाते थे, क्योंकि आप कैसे रहेंगे 7 दिन तक. जब the whole thing is over, then you made a good house. Follow this point on that time. हाँ? आपका जो ductile deformation है ना rock, it is following the same path. So there are languages, you know, we should learn. वो language क्या है? You see, your house was there, you know. So like, you know, the stress or whatever may apply. So now this is getting deformity. Follow this point now. ये कैसे होता है? आपका सपोज रॉक है, रॉक है ना, जैसे सपोज रॉक एक है, ये सॉफ्ट है, ये सॉफ्ट है ना, ये सॉफ्ट होने की वजह से क्या होगा? आप जब इसको ऐसे करते हैं, it becomes like this, एलिप्स बन जाए. आप सोचो ये एलिप्स ही हो रहा है आपका, ये सर्कल से it is becoming an ellipse. Follow this point. आपका ये मटेरियल से वीक था, तो गॉट टिल्टेड. तो ये क्यों, कैसे हुआ ये सर्कल टू एलिप्स कैसे हुआ? जैसे आपका ये मकान become tilted, you know, so many things are involved, you know, some part of it is flown away. So similarly also same type of phenomena happens inside the circle to become an ellipse. ऐसे कि आप तो देखते हैं, आप बॉल लेके जब रोटी बनाते हैं, बॉल लिया, आप प्रेस कर दिया, वो एलिप्स बन गया. पर उसके अंदर क्या होता है? वो एलिप्स क्यों बन जाता है? You don't understand this part or not? Tell me. Now, whatever happens to this house, you know, you just imagine. I'll write a name called diffusion. In geological term, I'm writing. Because the house is getting destroyed like this. Similarly, इसका जो structure था ना, ये circle का rock का, it is becoming an ellipse by diffusion. Diffusion is a process. वो समझाऊंगा उसको. But ये diffusion stage है. ये diffusion stage. There is another word I will tell you. Dislocation. डिसलोकेशन. जैसा इसका रूफ उड़ गया, इमेजिन करो ये डिसलोकेशन हो गया. डिफ्यूजन क्या, कुछ मटेरियल यहाँ से उड़ के उधर चला गया. ऐसे चीज हो रहा है ना हाउस का अंदर. तो ये सर्कल के अंदर भी सेम थिंग आर हैपनिंग, यू नो. कुछ डिसलोकेट हो जाता है, कुछ डिफ्यूजन होता है. अंडरस्टूड दिस पार्ट और नॉट? उस मटेरियल इज डिसोल्यूटेड, डिसोल्यूशन. These are three phenomena which is happening. Just like a house is getting destroyed, a circle is getting destroyed into an ellipse. ये डिफॉर्मेशन स्टेज है. आपको वो जो 3 फेनोमेना है ना, वो ये है डिसोल्यूशन, डिसलोकेशन. I can write this is 1, this is 2, this is 3. ये चीज तीनों इसका अंदर हो रहा है. So you are getting an ellipse. ऐसे आप देख रहे हैं ना बाहर से, you can describe this destruction of this house similar to the destruction of the circle into an ellipse by these 3 phenomena. So this is called a creep. Creep is nothing but a deformation, just deformation of body. So house is getting deformed. Follow this. We will describe these words, describe this term. But remember, your house is getting destroyed is similar to a circle is becoming an ellipse. Now, आप ये मकान को किया अभी? What did you do with this house? People, जब भी साइक्लोन हो रहा है ना, जब भी साइक्लोन हो रहा है, तो आप छोटे छोटे मकान बना रहे हैं, फिर मकान टूट रहा है. ये एक स्टेज है ना, ये स्टेज आपने तोड़ दिया है. ये स्टेज क्या है? डिफॉर्मेशन भी हो रहा है, प्लस आप कंस्ट्रक्शन भी कर रहे हैं. ये स्टेज है ना. यहाँ क्या है? देयर इज नो डिफॉर्मेशन, बट यू मेड अ गुड कंस्ट्रक्शन. 4 स्टेजेस ना, गुड हाउस, demolished house, destruction as well as construction, then full construction. These are 4 stages of making a house, you know. Same thing, you know, a rock, you know, a circle was here, it became an ellipse. वो जो ellipse है आप यही है. पर ellipse जब हो रहा है, इसका अंदर क्या हो रहा है? अरे भाई मेरे तो सर्कल था, अब मेरे को ellipse बना दिया ना. देखो, सपोज एक क्वार्ट्ज मिनरल कितना बढ़िया क्रिस्टल था. क्या प्रेस करके ऐसे बना दिया, कैन आई स्टे लाइक दिस, कैन आई स्टे इन ए क्वार्ट, ऐसे कैसे रहेगा क्वार्ट? क्वार्ट विल ट्राई टू रिकवर। मैं छोटा भले छोटा हुए, मैं अच्छा है कि ग्रेन बनाऊंगा, so that I can stay, you know. You understand your point, na? As you are making small houses because you want to stay with your family, you know, maybe 4 or 5 families you are staying, husband, wife, child, like this, you know. My family will be here. Maybe it is a big house, you are staying all 10 families. Now we'll make 10 small houses so that all 10 families can be accommodated happily. Though cyclone is going over it, you know. तो ये एलिप्स के अंदर वही बनेगा, वो रिकवर करेगा। तो अब जो एलिप्स पहले बना के फूट मोड़ दिया, वो एलिप्स अभी क्या चेंज करेगा? ये स्मॉल छोटा ऐसे करेगा। बट ये टेम्पररी हैप्पीनेस, यू नो, टेम्पररी हैप्पीनेस, बिकॉज साइक्लोन इज गोइंग ओवर इट, डिफॉर्मेशन इज गोइंग ओवर इट, यू आर रिकवरिंग जस्ट लाइक दिस, यू नो। तो इसको क्या बोलते हैं, ये स्टेज को क्या बोलते हैं ना? डायनामिक रिक्रिस्टलाइजेशन। यू अंडरस्टैंड व्हाट डज इट मीन? साइक्लोन चल रहा है, और मकान बना रहे हैं। हाँ, तो वही तो आएंगे ना, वो डिस्क्राइब इंडिविजुअल वर्ड्स ना, कैसे हो रहा है। इसलिए तीनों लिख दिया, क्रिप लिख दिया। क्रिप मैक्स एंड एलिप्स डिफरेंट वेज है। यहाँ आने के बाद आई टोल्ड यू इट विल रिकवर। रिकवर मीन्स न्यू थिंग्स इट विल कंस्ट्रक्ट। It cannot stay all along, you know. A quartz cannot remain a elongated quartz. It is to make, you know, small, good-looking quartz. But जो वो good-looking बना रहा है, उसका ऊपर भी चल रहा है ना. So that stays. So that is why dynamic. Dynamic came from here. Cyclone. Dynamic is cyclone. Recrystallization means recovery. मैं छोटा-छोटा मकान बना रहा हूँ, but ऊपर में cyclone चल रहा है. So this part is your dynamic recrystallization part. So छोटे-छोटे ग्रेन बनाएगा, बड़ा ग्रेन से छोटा-छोटा ग्रेन बना के ये एलिप्स टूट जाएगा। एलिप्स रहेगा नहीं, एलिप्स क्या करना का एलिप्स टूट। मैं पहले इतना बड़ा मकान में रहता था, तो क्या फर्क पड़ता उसमें? अभी तो साइक्लोन तोड़ दिया आपको, आप अभी छोटे-छोटे मकान बनाए, समझा ना? बट इसके ऊपर हवा चल रहा है, साइक्लोन इज स्टिल कंटिन्यूइंग। तो ये ग्रेन को ये तोड़ता होगा, फिर इंडिविजुअल ग्रेन्स ना दे आर वल्नरेबल फॉर बिकमिंग अगेन ब्रोकन। फिर भी वो घर वाले क्या बोलते हैं, फिर भी छोटा मकान बनाते हैं, तो 7 दिन तक रहना जो है। तो ये जो स्टेज है सबसे इंपोर्टेंट स्टेज इन डिफॉर्मेशन। डिफॉर्मेशन इज गोइंग ऑन एंड इट इज रिकवरिंग, गोइंग ऑन रिकवरिंग, गोइंग ऑन रिकवरिंग। अरे एबल टू अंडरस्टैंड ना? पहले जितना बड़ा बहुत बड़ा ग्रेनाइट था, बहुत कोर्स बड़े कोर्स ग्रेन थे। वंस अपने टाइम, यू नो, यू मस्ट हैव सीन एरिंगपुरा ग्रेनाइट, बड़े कोर्स ग्रेन उसका अंदर है। But when the deformation started, you know, in a ductile way, वो grain कैसे छोटे-छोटे होते हैं देखा? But deformation is going on. So just like a big house is getting broken into small houses. Dynamism चल रहा है, deformation चल रहा है, and it is recovering. When it is recovering, it cannot be a big house, because उसके ऊपर जो stress है, cyclone चल रहा है, तो इसीलिए ये छोटे-छोटे grains को बनाएंगे। But the moment छोटा grain बनता है, again it is broken. So it is not getting time, you know, to make bigger grain. No time for bigger grain. Bigger grain. बन नहीं पाएगा. Just like house, you cannot make a bigger house. So this process, dynamic recrystallization. Dynamism क्या कर रहा है? उसको तोड़ रहा है. Recrystallization क्या कर रहा है? रिकवर कर रहा है. एक कंपटीशन चल रहा है, आप कितना डायनामिज्म है और कितना रिक्रिस्टलाइजेशन है। डायनामिक रिक्रिस्टलाइजेशन, नॉट क्रिस्टलाइजेशन, डायनामिक रिक्रिस्टलाइजेशन। A competition goes on between dynamism and recrystallization. If recrystallization is dominating, bigger grains will develop. If dynamism is dominating, smaller grains will develop. Dynamism will not allow to make larger grains. Just like all this point, so this dynamic recrystallization, ये जो छोटे-छोटे ग्रेन डेवलप करता है, इसको भी इसमें there are 3 words, you know, grain bunching, GB, grain words you remember: grain body, grain rotation, grain migration. Right. Grain boundary migration, grain boundary rotation, grain boundary bulging. You can add on. इसको हम पढ़ेंगे. ये जो हो रहा है dynamic rectification, how it happens, these three ways we'll discuss. But remember what is dynamic rectification. If you see this picture, you will be able to understand. Both things are going together. Understood ना? Now अभी cyclone बंद हो गया है. अभी cyclone बंद हो गया है. Now you can construct. Those people can construct a big house. Big house. If they have a spirit to remain together. और ये देखा भाई इतना तो 15-20 साल से हम भाई भाई होकर रहते थे. ये तो साइक्लोन आके तोड़ दिया. So we will make our individual big houses. Try to make it big house where all 10 families will stay and quarrel every day overnight. Instead, let us make many such big houses. Though may not be as big as that, but quite big and good houses. आप उधर ले लिया मकान, उधर मकान ले लिया. ऐसे होगा. वो जो spirit बोला ना मैंने, if they have a spirit, they can stay together. Very big house they can build. Or if they don't have a spirit, they can have good houses, individual houses, but good houses. So that is called annealing. Annealing means there is no dynamism. Dynamism उसमें है नहीं. Only recrystallization to bigger grains. Annealing हो गया. You to understand this point now. Now you have good. The spirit is called temperature. There is a very high level temperature, then one grain will develop. If temperature is less, there will be smaller grains, but good grains. But ये grain में difference आएगा. यहाँ जब आप पहुँच जाएंगे, quartz will be good looking quartz, garnet will be good looking garnet. ऐसे grain develop करेंगे. But here they will be like this. Here anyway, all these things will discuss. So now we have these words: dissolution, diffusion, dislocation. Then we have dynamic recrystallization, grain boundary bulging, grain boundary rotation, grain boundary migration. Then we have annealing. So suppose somebody asks what is annealing, remember this. Everything is over. If suppose somebody asks you grain boundary migration, remember this picture. It is a dynamic recrystallization. If suppose somebody says what is diffusion, remember it is all a deformation process. House is breaking with a cyclone. Understood now? So you don't forget these three stages. If you remember this house picture, you can able to remember these stages. Don't confuse with this phase, with this phase, with this phase, with this phase. Temperature is what he says. Suppose when this deformation is taking place, because the temperature is high, then all those small grains will combine together to form a very large. If the temperature is not high, they will have good houses, not this type of houses, but separate houses. So we have different grains, separate grains, but temperature high means one grain will develop. One grain. No diagram. Yes. Because ductile medium means temperature is there. Temperature नहीं होगा तो ductile material नहीं होगा ना. But if temperature is high, थोड़ा सा कोल्ड होगा तो सेपरेट समझा थोड़ा. So next class we will explain individual terms I will explain.